Right, part A here. First of all, with this integral, we'll rewrite x, root x is x to the power half. But if we take it up as well, then that'll be x to the power minus half. Okay, take away then 6x to the power 4/3 dx. So when we integrate that then with respect to x, you add 1, so adding 1 to minus a half, you get a half. Divide them by that new power, which is a half. Take away 6 then, add 1 then to that power 4/3, add 1, you get 7/3. Divide them by that new power, which is 7/3 plus a constant. So just tidy this up. Half on the bottom, so take the 2 up, so you get 6. Now, you could leave it like this, or you realise, because it's x to the power half, that's just root x. Okay, it's often helpful. Take away then, we'll take the 3 up, so you get 18 over 7, so that'll be 18x to the power 7/3 over 7, plus then your c. Okay, and we're done. Part B then, it says, we've got a diagram here of the curve and the line y equals 4x. The curve and the line intersect at the point A, which is there in the first quadrant, and the curve intersects the x-axis at these 2 points, -1, 0, 6, 0. Show in your work again, find the x-coordinate of A. So you only want the x-coordinate, right? You don't need to find the y value here. We want to find out this here, of course. So we take the line and the curve, so y equals 6 plus 5x minus x squared, okay? And the line then was y equals 4x. And of course, where they meet here at this point, the y values are the same, the x values are the same as well, but the y values, more importantly, are identical at that point. So we could say that these are the same. In other words, we can put now 4x equals to 6 plus 5x minus x squared. Get everything to the left hand side, so you have x squared. I'll take that 5x over, you've already got 4x there, so 4x take away 5x is minus x, and then minus 6 equals 0. Okay, so when we factorize this, then you can have x bracket x, 3 and 2 should do us. Okay, so it'll be minus 3 plus 2 equals 0. So x plus 2 equals 0, or x minus 3 equals 0. So x will equal minus 2, or x will equal 3. Okay, so we've got 2 answers here. And they want the x coordinate of A. Now we've got 2 answers, x is minus 2 or x is 3. Of course, A could only have one answer. There's only one value for x. Just think about it logically. What could that be? Could it be minus 2 or could it be 3? And if you think about it, it's positive x values, so it has to be 3. Okay, so you can say, look, since A is in the first quadrant, as the question states, okay, the x coordinate must be 3. Okay, the minus 2, if you think about it, if this curve continued and the line continued, it would meet at some point. That would be the other point that come up there. So minus 2 would be down here, but it's the A we're interested in, that's all. So it says then find the shaded region here. And what I would do here now is think about the curve to start with, right? Don't worry about the line as such. And let's work out the area and the whole curve from this point here, which is minus 1, to this point here, which we've just worked out to be 3. Okay, so let's work out the curve area, all of that there, right? All of the area in the curve between minus 1 and 3. So minus 1 and 3, area under curve between minus 1 and 3, and the curve, of course, don't forget, was 6 plus 5x minus x squared dx. So then that would become 6x plus 5x squared upon 2 minus x cubed upon 3, between 3 and minus 1. So if we chuck those limits in, then okay, so we're going to have 6 times 3 plus 5 times 3 squared over 2, take away 3 cubed over 3, minus then, so I'll write it down here, I might run out of room. So we've got 6 times minus 1 plus 5 times minus 1 all squared upon 2, take away then minus 1 all cubed over 3. You can see my use of brackets. I'm being really careful, especially with the negative, of course. So let's get my calculator. 6 times 3 is 18, plus then 5 times 3 squared, all over 2, take away 3 cubed, all over 3, close bracket, take away, open bracket. Now 6 times minus 1 is minus 6, plus then 5 times minus 1 all squared, all over 2, minus then bracket minus 1 all cubed, all over 3, and close big bracket, and I get my answer out to be 104 over 3. Okay, so that's the area under the curve. Now let's go back to the diagram. Area under the curve would be all of this area here, okay, including what's under the line. If you think about it, if I got all this area under the curve, all I need to do now is work out this area under the line, okay, and then I've got, I can take it away. If you think about it, take this bit away. Now there is actually one quick way you could work out the area under this line, okay, maybe we'll do that in this particular question. You could integrate, okay, integrate this line between 0 and 3, and you get the area out, and then you take it away then from what we've just worked out, the area under the curve. Quick way of working out this area though, rather than integrating, is just to realize this is a triangle, okay, so the triangle of base 3, if we can work out the height, okay, so if we can work out this y value, and it's quite easy actually, because you've got y equals 4x, so when x is 3, here we're going to get 12, okay, this is going to be 12, so we've got a height here of 12, because when x is 3, y will be 4x, so 4 times 3 is 12. So the area actually then under the line will just be a triangle. So it'll be half base times height, so half times the base, and the base was 3, wasn't it, because it's going across the 3, and the height then was 12, so if you work that out then you get 18, okay. So then, as I said, you know now this is 18, so to get the shaded area you just take the 18 away from the area under the line, okay, so the shaded region will equal the 104 over 3, take away the 18, and we can get our answer. The answer that was there previously, take away 18 is 50 over 3.